I introduced you what this functions as data concept, right? This is now it's there in many languages, but yeah. So lambda expressions are basically it's basically a way of having functions as data, right? It allows you to have functions as data, but lambda expressions, you will see that it's more of we will cover that in this class. But before we go there, we need to understand that you can actually have functions as data in Lisp, and the whole objective of having that was for making something generic. So if you had gone through yesterday's lecture and slides, you would see that yeah, and if you went through that and you understood the concept, you can see that how you can plug and play the functions. All right, so you can, it's called he's calling it functional abstraction. So it's a different way of looking at building programs. All right, so you would, in object oriented programming, there's a concept of object, and you abstract away, you do inheritance, and you do polymorphism. So you have various features that the paradigm provides that you can use for structuring your program, all right, or structuring your product or whatever. So software engineering in the real world, it requires some amount of organization and planning. So these constructs help you to structure your code well, okay, and structure the functionality. So in Lisp, it's more of functions are very the core feature of Lisp and Lisp related languages. So you can actually use them to structure your code, okay. So this is something called functional abstraction, and in that the key aspect of that is what we had a look at yesterday, where you can actually provide you can define a function, and we provide a function as data to another function, okay. This is the crux of this higher order functions, and they are known as higher order functions. So higher order because the function, you're defining a function, and that function itself takes another function as input, okay. And we'll just get to the core of the lecture. So the thing that we introduced was a function object, which is equivalent to a special the syntactic sugar for that was hash code, and it provides you a function object. So we are defining functions, okay, and I showed you that you can actually split the defun macro. It just provides you a name, but the actual function definition is what matters, all right, because you could have a different symbol, you can attach any symbol to it, but the way the function definition is what matters, because the function definition internally it creates some representation of that function, and then it provides you, it saves that into a variable or symbol. So that symbol will store the definition of the function, and yeah, so defun macro is one kind of thing. So you just have to in order to understand lambda expressions, you have to understand that the definition of the function and the symbol used to invoke the function are two different things. So you could have like same definition but different symbols, and so that hash colon gets you the object itself. Yeah, what we did was jump in some sense, okay, even though at some level it's just calling using it's again a Lisp form. So we are actually using Lisp forms, but the kind of thing we are doing with that is quite substantially different. So func call is at the end of the day, if you could say that, okay, I have defined as let me just do something else, let's say plus, okay. So we know we have this plus function. Function, you can say function of plus, that will return me the internal object of plus, okay. And then what am I doing? Func call of function. If you want to do it in the functional approach, you want to write down the whole thing, and this is what we are doing. So this will give you 0, and then you can actually do 1, 2, 3 like this, right? I hope that this is clear, okay. So here if you just go through this, there's no point of having a func call. It doesn't make sense, right? Why would I do this? It looks like a roundabout way of doing the same thing. But the shift you have to see is that here there is a shift in the sense that everything is now part of an input to func call, right? Func call is another function. It's a function, yes. It Lisp provides this function for you. Okay, I can also say something like this. right? So you can see that it's actually a function, right? The fun call itself is a function, and you can also say, so you can do this type of crazy things, but yeah, function is a special operator, I guess. Yeah, function is a special operator. Let me just verify that. Yeah, it's a special operator. All right. So the special operator, you cannot use it in a function, but you can say function of fun call, which gives you a system function call. So it's a system function, and similar to this. So I hope this part is clear. So this is the so it's just what this tells you is that in Lisp you have a way of differentiating uh, between the definition of a function, the actual work that is being done, and the symbol that is being used to represent the function. So for example, I can say setf my fun call, and I can say fun call. I think I can do this, or yeah, or let's just put it as plus. All right. So my fun call is set to plus. So I can always use that to define my to call that thing. Okay. So basically it will be yeah, it's not there. So I guess you have to do something more. Yeah. No, this plus is deceptive. So let's use some other thing. My fun call of I define another function. Okay. So basically square is basically taking a square. Okay. You can say square is this. Okay. So I have defined it before. So no, it's not defined. So anyhow, we'll get to this thing. There's some way of setting a function. Okay. Yeah. Okay. Anyhow, so yeah, also this is might be a bit more involved. So anyhow, so let's just define. I have defined a simple square as this function here. Okay. Yeah, this is my square function. Okay. So basically, what I'm doing is I'm extracting the functionality out of it. I'm getting the object out of it. Sorry, function. Using function, I'm getting the object out of square. Okay. And setting it to another variable, we'll see that, but right now we don't need it now. So this is also another way of doing it. So this is another way of getting the function object. These two are similar things. Okay. So you get the function object, which is the internal representation of the function. And then once you get that, you use fun call to call it, basically. All right. So that's the thing we covered here last time. And you get the input. Right. So this is clear, no? So again, going back to the initial observation, that what is the point of having this when why do I need this when I can just call it directly? So the point here, you have to see the difference is it's visible upfront itself, because you are not, you are now providing this as an input to funcall. I hope you see that. Funcall itself is a higher order function, because funcall itself is a higher order function. Funcall is a function, it's also a higher order function, because it is taking so first argument, it is taking the function definition, and then it's using the, you have to provide the arguments. If I were to do this, basically it will throw you the same error, what it would have thrown for that particular function. So the arguments for that function should be appropriate. Okay. So second argument should, the arguments after the function definition should match the function that is being supplied as input. So that's what fun call requires. But you can see the fun call itself is a higher order function. I hope that's clear. And in fact, you can also say you can get the object for fun call. All right. So the fun call itself is a function which has a representation within it. All right. So this is fun call definition. Now what we do is we now move on to the example. Okay, we had an example last time. and what did we do? We did this, right? So we covered the plot function. So I mean, you can see the fun call itself is a higher order function, but you can question like what is the value of this when I can might as well do square 11. Okay, so it doesn't make sense to have it to just to call it in this on the outer level. But the point of fun call is you can use that to build other functions, build other higher order functions, and plot was one example. Plot was an example of a higher order function which takes in as input a function. Okay, so the function definition, and notice that we are not providing the variable. We are providing the we are expecting a function object here, because at fun call we are just calling it as it is. So we are expecting a function definition to be provided as input. The function object should be provided as the input to this. So that's the expectation there, and basically I have defined two functions now. Okay, I just showed you square xpt by 2. To make things simple, I have defined this function. There's a function called so what does this thing do? So by the way, so this is a part of common Lisp, and I found this from, you can actually see this and this similar types of functions here. This is the link here. Okay, this is the hyperspec, common Lisp hyperspec. All right, so these are the chapters you have. This is okay. This is also they may have some lot of it's not exactly, they're not teaching things, but you can refer things, and if you have some doubts, you can always go into that, and you can look into it. It's very nice article. It's very old one also, but it's looks very good actually. It's like it's very very detailed, and you can use it for reference. Okay, very detailed and very informative. So I got this function from there. So that was this expt. All right, you can also do a search in this thing. Very nice kind of, the content is very good actually. So you can have a search here, and you can also look up certain things. It's very comprehensive and very detailed, so you can have a look at it. If you have any doubts, you can only go through this. So this is the content list. It's kind of like a book, all right, but it's basically a reference. It's for reference, so you can refer anything you want here. So printer, reader, and you have evaluation, how it is happening. All right, so it's in detail, so you can have a look at it. Basically what this xpt does is, so exp was a natural log. Okay, but I want this thing. All right, so what does this thing do? Expt is a function. Okay, so what it does is basically it takes you have to give a base number, and you have to give the power number. You can see what is given here, because exp is fine, it gives you a natural log. All right, but expt is much more discrete, so we can use that for doing I mean, basically it returns a base number raised to the power number. This is what it does. Base number and power number, and gives the result. So you can stay in the discrete thing, and if you do this, what will be the result of that? So yeah, take note of this. This is a very nice useful reference site. It has everything in detail, and you can go digging into it once if you can cover the basics. You can always look into the more advanced chapters. It has it in detail, so each of those are organized very well actually. Now we want to know what will happen with the expt. Expt basically takes 2 and takes it to the power. So if you have to go to Python, it will be something like this. Okay, so what is this? Basically it's 1024. Okay, it's like 1024, and then if you go for this, it's 2048, right? So it's basically exponentiation. Okay, this is what you call gigabyte. 1024 MB is a gigabyte, right? And similarly you have like 4 GB and so on and so forth. So we are raising a number to the power of 2. Okay, so expt is that, but what I want here is the issue is that I want a function. Okay, this takes 2 arguments, so I cannot provide this as this into this. Is it correct? Is it clear? So I have to define a function that has to be of this signature type. It should take in one value and return a value here, so it will then loop that many times. Okay, So in order to do that, what I did was I defined this function called. You can actually always convert. You can, if you want to abstract out. So this is one way of abstracting things out. So I have a, so I don't want to use exp because that's, giving you decimal points. I want it to be, concrete, and I wanted to define it like, basically like with the integers. Okay. So, but the issue was, see, the signature of this thing is it has two arguments. I cannot provide it into this plot function as it is defined here, because the plot function takes a function, and if you see how it is being applied here into func call, it only takes one argument. All right. And we don't know how to supply this. This would break as it is. If I were to supply this into here, it would break. Right? It will not. It will throw an error, because let's try it out also if you want. So I just want to do expt. Okay. Expt. All right. Let's just say expt. This doesn't make sense, right? This would not work. So as it says here, it's to few governments you do expt because of the application here. First of all, I want to raise by 2. So I would do it like this. Okay. I define a function called, I'll just do this and I'll explain it for you. And I do an x here. Okay. And then I do expt to x. So now what I have defined? I've defined a function called expt by 2, which is which satisfies this thing here. Okay, internally it does that. It takes a base number 2. It has fixed the base number. This is called, this is one type of abstraction actually. So I am taking a function that has 2 arguments, and I'm converting to it, I'm using that to create a function with 1 argument. So my base number, I fixed it. Okay, and then I'm going to vary my, I'm going to vary the power number. Okay, I could also do this. What is happening here? I could also do like this. Yeah, that would be a square actually, right? Power by 2 would be a square if I do it this way. This is also fine. This is also a proper thing, but this is square and this is cube and so on. So you can also define from expt, if you fix this the power and you vary the x, you will get a different result. This will be cube, power by 3. Okay, raised by 3. All right. So that should be doable. I mean, it should be understandable. Now what I do is I can go to plot, and then I do this. I call this thing. So we can use that definition. I can now do this by 2. All right, 1, 5, and 1. All right. So what has it done? So first one will be 2 times, second will be 4, this will be 8. You can verify that actually. This will be 16 and this will be 32. 32 times. Now that same function, I can also say, okay, raise by 3. This will give me a different result. All right. Now raise by 3 is much larger. The one that you can see it's like that. It's just fine. The 2 2s are 4, 8. But of course, as you go by bigger, this will, it will just blow out more than this this thing. For small numbers, it looks like very large, but that's the point here. I can also say, I hope that's clear now. So you've seen fun call, you've seen function, and you've seen the point of having a thing. So what's happening here is this plot, right? Plot is the higher order function, and it in turn takes in this fn, and it uses func call to apply its argument. All right, and then it applies it in that context. I hope that's clear now. This was an example for higher order functions, and we have completed this thing now. Let's go to apply. Just like invoke, fun call, apply is another thing that you can use. Okay, so in order to understand the value of that, imagine that we have this thing here. Okay, let's go back to the example. Now what I want to do is I want to have plot, okay, but I have set plot data to be of this form. So the plot data list, but what it has is it has the inputs to this thing. So if I were to just imagine I have the set few plot data and I want to invoke it, okay, I can do this now. This is basically coming, we did list earlier. So a list is actually, you can use this, these are shortcuts for, to get data out from a list. The third element, and you can do this. These are functions that you can use on a list to extract that particular element out of it. If it is not there, it will be undefined, it will be nil. For example, so this is present, it's 1, but if I do something like fifth, that's going to give you nil. Anything beyond that will be nil. So it's well defined, and it's just that if it's not there, it will be nil. That's it. So we have this now. Now what we do is basically we call this function, and it will behave as expected. But this is really cumbersome. Okay, it's really inconvenient, and sometimes you may not even know. So in this example, we know what structure of this plot data should be like, and it's very rigid because it says you have to have 4 elements at least in order for this guy to succeed, right? And yeah, so now what does apply do? Apply can be used in the above context, okay? And how does it do it? It's like this. So you can actually say apply hash colon plot. So you know that this is the it has all the data that you need, okay? Is it clear? This is an example application of apply. So apply, what it does is, okay, you give me an function, okay, you give me the function object, all right. So you got the point, right? The function of plot is a function object, okay. So it as a func call, it takes in a function object. I think this will also not work because you need to say it this way, okay. So this is same as this thing, and apply, what it does, it takes the function object, it takes the plot data, and it feeds that plot data into this thing. So fun call, you have to specify each of them one by one, all right, but you need to know upfront how many arguments it will have. For example, right, this will work. I cannot miss this out, and I cannot use lists. So it's kind of rigid, okay. It's rigid in the sense it expects you to provide every argument as it is, or you cannot miss out any arguments, as it has to be as per the definition of EXPT, the function that you're providing. So the function that you're providing as first argument determines how many parameters you should have after that, okay. Fun call by itself doesn't restrict you in the number of arguments, but the function that follows it determines what arguments you should have, what it should be, what determines the rest of the parameters for fun call, all right. And also one more thing to notice is that EXPT, the function that you're providing, it can have optional arguments, keyword arguments, and the like, okay. So that's why this parameters is very important to know. So if fun call will the thing that, but whatever it is, fun call is dictated by the arguments to fun call. The second and following arguments to fun call are dictated by the function that you provide as input. This itself is of a higher order function. The function that you provide as input determines the what is allowed to produce in the provided in the following things. But apply, what it does is, apply is very flexible. First thing you can do this, okay. So you can provide it as a list. That's the first thing you have to do. So you need not know what arguments, as long as somebody is giving you the plot data, you can abstract away you don't have to provide it at the application stage. So but you have to ensure that the plot data is proper. But you can also apply is also flexible in the sense that not only can you give plot data as a single variable, you can also do this. It also accepts loose arguments. meaning that I can also say something like, okay, I would like to give you the function up front, but I want the plot args to be like defined by the end user. Okay, I want to fix this arguments. Okay, let's say, then I can provide q, I can apply hash code plot first, then I can give plot args. Okay, but this is not sufficient. In between I have to also say that, okay, is it square? All right, this will also work, and then I can also give it all right, this also works. The reason so what have I done here? I have abstracted away the arguments into one list, and I provided this thing. So in this sense, it does the thing. You can also do something like, so you can see the flexibility involved here, right? It's quite flexible. I can also do this. I can say, okay, I fixed the first argument, and then I do this thing. So these are some things you can do. You provide 5 this, or you can just go back to like fun fun. Yeah, you can't do that because I guess you need a function. You need at least one list. Yeah, so this will be what you need to provide it as one list. At least one list needs to be provided, and you cannot do it like this unless I think you can do this. Yeah, this is also possible. Get it right. And you can also give junk here. I guess this will also work. I'm not sure, but no, it doesn't. Okay. So yeah, so basically what it's doing here is this is basically func call, right? Except that you have this extra nil here. You can also do it like this though. Okay. So you can also do this thing. Alright, so it's quite apply allows you to unpack your arguments or combine them together in one thing. It allows you to unpack or combine. So this is the kind of things that's possible with this thing. But the only condition is that, so it allows you to provide loose arguments. The function being applied, the function that you're applying, right? Even fun call also allows you the function that is being applied. It can take optional rest and keyword arguments. But the only thing is that the argument list that you produce must be accessible to the function. The whatever you are providing here, it should somehow match the definition of the function you have provided. After reducing, the apply will take care of certain things, and it will combine all of those arguments, all of the following arguments. It will combine together and it will form some list. All right, and it will feed that to the first function. So that should be well defined. So we are done with apply. So yeah, it could be. So you just start with this thing first. So understand this part, that this is the easy case for apply. So you just provide the data, you use the function, and you can apply the data. You can construct the data, and you can apply it as a list. But you can also unpack. And you can unpack the first thing out, and you can give plot arguments as input, only the arguments. Okay. And there's a lot of flexibility in this. If not, we can go to lambda expressions. Finally, we are coming to lambda functions. Okay. So lambda functions, the thing is, it's just do lambda, you give parameters in a body. All right. So there's no defun here. So in defun, I'm not sure if lambda is a macro or what is it. I'm not sure, but yeah. So we don't know exactly how it is implemented. Just think of it as a language construct that is provided by Lisp. So it just says parameters and then body. And these parameters, again, they could be like, I guess we have optional. We'll look at it, okay? So when we use it, you need to create an anonymous function using a lambda expression. It's when you don't want to, basically one scenario is when you're lazy. You don't want to define, or you find that it's overkill. You don't want to use defun and define a variable and do this thing. You just want to have a function on the fly. All right. Okay. So this is the thing here. Wherever you use a name, you can use a lambda expression. Okay. All right. Wherever you use a function name, you can use lambda expression. So for example, here I would have put in a exp there. right? Expt by 2. Instead of doing that, what I can do is, okay, what is expt by 2? It's basically a lambda. I can say lambda, all right. And then what the it's basically a list expression. Notice, remember that yeah, lambda is a special keyword, okay, but the rest of the things will be a symbolic expression. I want you give me an x, all right. So if you notice that the expt by 2, I don't have to define it upfront. That looks like an overkill, all right. What I have to do is I can just say lambda x. I can use it where I need to use it. expt to x. Okay, I have found that. Now I can then use 5, which will give you the required thing. So instead of defining expt by 2, I could have said lambda x, all right, and then define what I want to do. In that, the definition of the function is defined like this, all right. So it's this anonymous functions. There are no names for it. You don't need to name it also. You give a lambda, and you just define to me what the behavior. They define me the function. That's it, and use the function in this context here. This is what it's doing. Okay. So I think that with that, I guess the lambda expressions are clear now. So instead of using this, I can say, do it like this. Okay. So I don't tell you the name of the function because I don't need it. I already have this. I know this is the expression I want to use in this context. Okay. So I give you the thing up front. All right. And you can also do it like this, like yeah. So there the x plus y function is defined. Another aspect of it is, yeah. So instead of the name, so expt by 2. This is a function call. This is fun call. I use it as fun call, but I can also do this, right? So I'm using it in anywhere where you use a function name, you can actually replace that with the lambda expression. Lambda of x. Then this will give you a function. This will throw an error because it doesn't have any enough arguments. All right, because it's an expression that has one variable free. Okay, it is not bound to anything. You can think of if you go back to the binding thing, that expression has x is actually unbound. All right, and yeah. Yeah, so that's the short of it. So you can use this as a lambda expression, and you can use it to instead of defining a function and then using it. Since this is a very short expression, right? I can just replace. I can just create the function on the fly wherever I need it. So that's the gist of it.